Hello.
Hello.
Yes, my dear students.
Yes. Yo.
Are we understanding what I'm talking about? Yes? We are together, eh? Members, are we together?
Yes.
Okay. So can we proceed? Can we proceed? So even our R, our I was 30 degrees. Then angle of refraction was also given to be 19.5. They want us to find the refractive index of glass. So this is NA, we know is 1.00. But we are assuming that we don't know the refractive index of what? Of what? Of glass. We assume that we don't know. We want to prove it by calculation. We want to prove it by what? By calculation. Theoretically, we know that what is the answer? What is the answer? What is the refractive index of glass, members? Theoretically. Theoretically, angle of, refractive index of glass is what? 1.5. So let's prove it by calculation. Let's prove it by calculation now. Let's prove it by calculation. So you said from Snell's law. That's your foundation. That is your foundation from Snell's law. So is moving from air to glass. So it will be sine A, NA, sine I equals to NG, sine what? Sine what, members? Sine what? R. What do we want to find? We want to find what? NG. So which means if I make NG the subject, if you make NG the subject, what shall we get? What are we going to get? Just a moment. Just a moment. So if I make NG the subject, NG, we shall have N what? A over sine what? Over sine R. Right? Members, is that clear? So let's make the substitution now. So NG will be equals to refractive index of air, we know is 1.00 times sine of 30 degrees divided by sine of 19.5 degrees. So our NG will be equals to, so put everything in your calculator. Put everything in your calculator. Put everything in your calculator. Members, are we together?
I have a question.
Yes, Alexandra.
Teacher, the question is saying that a ray of light is incident onto a glass at an angle of 30 degrees from air. So you were saying that we are moving from air to glass, but the question is incidenting onto a glass at an angle of 30 degrees from air.
Yes, which means from air, which means light is traveling from air to glass, from air to glass. Okay?
I thought it was from glass to air.
No, because I'm saying from air. Okay?
Okay.
Yes.
Thank you.
Welcome. So can you press for me that and get the answer, please? So we shall have, you put everything once in your calculator, open a bracket, So 1.00 times sine of 30, close that, divide by sine of 19.5. What do you get? Is 1 point? We get 1 point what? 1.4978, like that. But if you round it to 2 decimal places, you find out we shall have what? 1 point. If you round off this, you find it will give us 1.5, 1.50. Are you together, members?
Yes.
Yes, that's how you should get it. Yes?
Teacher,
Yes?
is it a must that you are supposed to put?
To what? To what?
Is it a must that we are supposed to put brackets?
Yes,
To
yes.
put brackets.
To separate the denominators from the denominators, okay? You have to open a bracket for this, then you divide it by that, because to separate the denominators from the denominator, okay? Yes, that's a correct use of calculator. That's a correct use of calculator. Can we look at question number 2 on our screen? Question number 2 on our screen. Question number 2 on our screen. Please, if you have nothing to say, please can you mute your microphone? Margaret, there's a lot of noise in your background. Members, can we look at question number 2? On our screen, but now this one become number 3. This one become number 3.
Why are you not doing work?
So we have that saying a ray of light traveling through air, strike glass at an angle of 40 degrees to the surface, given that the refractive index of glass is 1.545. Find the angle of refraction, angle of deviation through which the ray is bent from its original direction. So let's have a ray diagram. Let's have a sketch for that. Let's have a sketch for that. Is from air to glass. It must be in pair, members. It must be in pairs. It must be in what? Pairs. So we know that this one will bend towards the normal. So this is that. This is our angle of refraction R. Then this is our angle of incident I. And it's moving from light is moving from air to glass, like that. So it have also given us that the refractive index of glass is 1.45. For air, just know is 1. For air, just know is what? 1.00. Okay? So when you look at the question, there's something that they have hidden there. There's something that I've hidden there. They've said light traveling from air strike glass at an angle of 40 degrees to the surface. Which surface are they talking about? Is this one, members? Is this one here, the boundary surface? So this angle was given to be 40 what? That angle was given to be 40 degrees. It was given to be 40 degrees. So what is the angle of incidence now? Who can give us what is the angle of incidence?
50 degrees.
So angle of incidence, why are we saying 50? Because I plus what? Plus 40 degrees must give us 90 what? Must give us 90 degrees. Must give us 90 degrees. So which means I will be equals to 90 degrees minus 40 degrees. So angle of incidence is what? Is what? Is 50 degrees.
50 degrees.
Now to find the angle of refraction, to find this angle, what do we use? We said from Snell's what? From Snell's law, which we shall have NA sine I equals to NG sine what? Sine what? Sine R.
R.
What are we looking for? We are looking for R. So which means it implies that sine R is equals to NA sine what? I over what? N over N what? Over NG. Not so, members. Not so? So from there we start the substitution. So this is 1.00 times sine of what? Of 50 degrees over refractive index of glass, which was given to be 1.45. So you have to follow what is given in the question. You have to, theoretically, we know that refractive index of glass is 1.52, but sometimes it keeps varying on calculations. It keeps what? It keeps varying. Are you together, members?
Yes, teacher.
Yes. So now, can we press that? So sine R will be equals to, so we'll have open a bracket, 1.00 times sine of 50 degrees, close that bracket, divide by 1.45. We get what? 0.5 to what? To 8. We said we write to how many decimal places? To how many decimal places?
3.
To 3.
3.
So which means R is equals to what? So it implies R is equals to the sine inverse. Equals to the sine inverse 0.5 to 8. So therefore our R will be equals to, you press shift sine. Answer. What do we get? 30 what? 31. We said we write, so if you round it up to one decimal place, what do you get? Point what? 0.9.
9.
So that's the angle of refraction. That is the angle of what? Refraction. Angle of refraction must always be less than the angle of incidence. You should know that. Okay, it depends on how it's moving from one medium to another. If it's moving from air to glass, the angle of refraction in the glass must be less than the angle of incidence. But if it's moving from glass to air, the angle of refraction must be more than the angle of incidence. Are you together, members? Why? Because of the difference in optical densities. Because of the difference in optical what? Densities. So have you answered all the questions? Members, have you answered all the questions? Yes, or team? Have you answered all the questions, or team? Francis? Okay.
Not yet.
We have answered part 1. We are through with part 1. So this was part 1, right? It was part 1. So part 2, what do they want? Angle of?
Deviation.
Where will the deviation be? Deviation will come from here, members. Deviation will come from here. So members,
Yes.
it's like when do you remember from reflection of light? So which means if this light was, if this reflecting surface was not there, which means this light would what? Would continue moving in a straight line, not so? It will continue moving in a straight what? In a straight line.
Wow.
So this one here. So this one here. This one here. This one here. I think that, members. So this is what we call this now the angle of deviation. I think this, members, this is the angle of what? Deviation. So that will form first the angle of deviation, like you can see from our diagram there. So which means for us to find the angle of deviation, what do we need? What do we need? What do you need? Which concept? Now, here now you have to remember mathematics. You have to remember what?
Mathematics.
Mathematics. Like when you see this line, I think this line here, I think this line here. And this one here.
Yes, teacher.
So when you look at this angle together, members, let me put it like this. I think this one here and this. What can you say about them? They are vertically opposite angle, no sir? I think it.
Alternate interior.
Is it opposite or alternating? Members, is it opposite or alternating?
Opposite.
Opposite.
They are opposite what? Angle. So which mean, and opposite angles are always what? Are equal, right?
Equal.
So which mean angle I must be equals to what? Must be equals to R plus what? R plus
D.
R plus D. R plus D. So we want to find D. So which means D is equals to I minus
R.
I minus R. So D will be equals to, what is our I? Our I is what? 50. Minus
50.
Our R, which we have just got, is what? 31.9 degrees.
9.
So what do you get? What do you get? What do you get? What do you get?
10.1.
Is what? 18.1 degrees. 18.1 what? Degrees. So as simple as that. As simple as that. Any question? Okay, let's move to the next number here. This one we have very many set. I think this one we can do it. This one we can do it. But let's go to question number 4. Okay, let's go to question number 4. Members, are you seeing question number 4 on our screen? Members, are you seeing question number 4 on our screen?
Yes.
Can you copy that question? Copy it down, put it down. So they're saying a diagram below shows a liquid sandwich. Sandwich is to embed them, is to combine them together between two glass slabs of refractive index 1.5. So they're saying a ray of light begins from the upper glass slab, and it later emerges into air. It emerges into air. So let's sketch that. Let's have the sketch of that. So this is now our question number what? This is question number what? Number 4, eh? This is our example number 4. Members, no, don't worry about the diagram. What is important, as long you just take pair of media. You just take a pair of what? Of media. Right, together. You just take a pair of what? Media. So we have the first one here. Then another one here. Hey, sorry. Let me use this side now. I want to be organized in my work. So this one here. Then there's another one here. And there's this one here. Like that. So this is glass. This is air. Then this is liquid. This is liquid. Then again, glass from down here. Then there's glass. There's what? There's glass here. Then back to air. Back to air. So it started from here. Started from here. This is our normal. Light is incident like that. So make this angle a little bit big, like that. Is refracted from here to this point here. So we create our normal line again from there. So it will create a normal on that surface, like that. So this one is again from glass to air. I mean glass to liquid. If you compare glass and liquid, which one is more dense? Glass and liquid, which one is more dense?
Liquid. Liquid.
Liquid is more dense. Really, members? Liquid is more dense.
Glass.
It's like if a solid and a liquid, which one is more dense? A solid and liquid, which one is more dense?
Solid.
Solid is more dense. So what will happen to here? Which means light rays will what? Will bend away from the normal. Will bend away from the what? From the normal. So it will be like this. You don't just draw, you must follow the science. You must follow the what? The science. Or the physics behind it. Then now we have glass and liquid and glass. What will happen to it, members? What will happen? What will happen to the light rays? Will it bend away or towards the normal? Away from the normal or towards the normal? It will be towards the what?
Towards the normal.
It will be towards the normal. Good. Again, we are here. We are here. And then we have glass and air. Is it going to be away from the normal or towards the normal? Towards. Air and glass. Is this going to be bent away or towards the normal? It's going to be away, not so. It's going to be what? Away from the normal, like that. So this is our ray diagram. So this is our ray diagram. This outline is moving. This outline is moving, like that. So they've said, they've called this one point, they've called this one. So they've called this point A. They've called this point A. Then this one B. B. Then this one C. Okay? So this angle was given to be, 40 what? 40 degrees. Then this angle was given to be 50 degrees. Like that. Members, have you seen that? So this is the liquid. This is our liquid. Our liquid is there. This is our liquid. Just to show that is a liquid, I can put something like that. Now, what do they want? What do they want? They're saying that find the refractive index of the liquid. Find the refractive index of the liquid. So if you want to find the refractive index of the liquid, which pair should we use? Members, which pair should we use? Which pair should we use? We use glass and what? Glass and liquid.
Glass and liquid.
Because this one, we know the angle of incidence here is what? What's the angle of incidence here? 40. Then what's the angle of refraction here? What's the angle of refraction here? 50. So using glass and liquid boundary, using glass to liquid boundary. That one, where the angle of incident I is equal to what? 40 degrees. Then the angle of refraction is what? Is 50 degrees. So from Snell's law, from what, members? From what? From Snell's law, which is going to be Ng, because it's from glass to liquid, sine I equals to NW. I mean, of the liquid. So let's use SL because we don't know the liquid. If it's water, we would have used W, but I would just say liquid. Sine what? Sine R. Sine R. So I want to find this one. So I will make NL the subject, NL the subject. So it implies that NL the subject will be NG sine I over sine what? Over sine R. Members, are we together? Can we substitute? What have they said? If you look at the question, they've given us the refractive index of the glass. The refractive index of the glass was given to be 1 point what? 1.5. So NG was given to be 1.5. You use that one which was given. So 1.5 times sine of 40 degrees over sine of 50 degrees. So what do we get? What do we get? What do we get? We shall have, open a bracket, 1.5 times sine of 40 plus divide by sine of 50. Members, what do you have? Do you have the same value like mine? 1.2586. So therefore, if you round it to 2 decimal places, what shall we get? 1.2 what? 1.26. My dear students, are we together?
Yes.
Members, are we together? Are we together? Lynette? Lynette, Mogoya Lynette.
Yes, teacher.
Lynette?
Yes, teacher.
Are we together, Lynette? Let me see who was from Lira. Who is this person from Lira? Tracy. Tracy, are we together?
Yes.
What about Wilma?
Yes.
Very good. What about from Eganga? Lamuno? Lamuno?
Yes.
Are we together?
Yes.
Even, Lamuno, what is
Yes.
Okay. So have we answered all the question? Have we answered all the question? Number 2, that's saying we should find the angle of what? Angle of emergency, E. This one here. So this angle was given to be E, angle of emergency, E. So how are we going to find this angle, E? We must do some mathematics, not so. We must first do some what? Some mathematics, not physics. Members, if this angle is 50, analyze the diagram very well. If this angle is 50, what is this one? What is that angle? What is this angle? This angle is also what? This angle is also what?
50.
Which property did you use? Which property did you use? Alternating? Members, they are alternating what? Angles. They are alternating angles. So if that angle is 50 degrees, if that angle is 50 degrees, if that angle is 50 degrees, then what about this one here? So which means we need to find this angle here. Are you seeing this angle here, members? I think that we need to find this angle. So this is, let's call this angle R. So this is the angle of refraction in the glass. Angle of refraction. So we are using liquid to glass. Liquid to what? To glass. So that we can find this angle R, because after finding this angle, then we can find this angle here. Then this angle will also be R. This angle will also be R. Members, have you seen that?
No.
I'm saying this angle is 50, right? This angle is what? 50. Because there's no way we can calculate angle E without knowing this angle here. We must get this angle here, because this one is the angle of incidence between these two media, air and glass. So for us to find that angle, we need to know this angle here, which I will label it as R, the angle of refraction here. So that after getting R, this angle is also become R. Then I will use these two angles, E and R, to find this angle here. Have you seen that now? Have you seen that? So let's find this angle R here. Let's find that angle. So which boundary are we using? We are using liquid to glass. Liquid to glass. Liquid to glass boundary. So still from Snell's law. Still from Snell's law, which we shall have NL sine. What is this angle here? The angle is what? Angle of incidence here is what? 50. I equals to N glass sine R. Sine R. So what do we want? We want to find R. But NL is 1.26. We have just calculated it. We got 1.26. Then angle I is 50 degrees. Then NG is 1.5, which was given. Then R is what we are looking for. R is what we are looking for. So which means it implies now NL sine I equals to NG sine R. So make R the subject. So if you make R the subject, you shall have sine R equals to NL sine I divided by N what? Divided by NG. So you find now we shall have sine R equals to 1.26 times sine I, we said is 50 degrees from our diagram, over 1.5. Over 1.5. So you find that sine R will be equals to, take your calculator, open a bracket, 1.26 times sine of 50 degrees, close that, divide by 1.5. We get 0.643. So which means R is equals to the arcsine of 0.643. Therefore, our R is what? What will be our R? The sine inverse of that. Sorry. The sine inverse of 0.643. The answer is what? What is the answer, members? Is what? 40 degrees. So it's 40 degrees. It's 40 degrees. But is that what we are looking for? No, we are looking for E. We are looking for what? E. So now I've got this angle here. I've got this angle R here. But using the properties of alternating angles, we find this angle is also going to become what? That angle is also going to become R. So now using glass and air. Now we are using glass and air to find angle what? To find angle E. To find angle what? E. Are you together, members? So let me use this site. Let me use this site. We are running out of time. We are running out of time. So using glass and air. Using glass and air. So which means we shall have still use from Snell's law. From Snell's law. So we shall have glass sine I equals to NA sine R. That's the general formula. But we shall have NG sine R. Okay? R, because this angle is R. Equals to NA sine E. This one is E. This angle incidence is E. You can see from there. So I want to find E. So which means sine E will be equals to NG sine R over NA. Over NA. But we know the refractive index in air. What is the refractive index in air, members? Refractive index in air is what? 1 point is 1.
1.0.
So which means sine E is equals to 1.5 times sine of what? R, which we have got, which is 40, sine of 40 degrees, divide by 1.00. So you find that our sine E will be, our sine E would be 1.5 times sine of 40 times sine of 40. So we get 0.1, because if you divide by 1, you still get the same value. Divide by 0.9, I mean 0.964. So which means E will be equals to the sine inverse of 0.964. So what do we get? Therefore, E is equals to received sine of that. What do we have? We have 70 what? 74.618. So therefore, if you put it to 1 decimal place, you find our angle will be 74.6 degrees. Members, are we together? Are we together? My dear students, are we together?
Yes.
Bazara. Trenema. Krenima, your network is bad. Don't talk. Your network is not good. Don't talk. Your network is not good. Don't talk. Don't talk. Don't talk. Don't talk. Sandra, Margaret, Farouk. Are we together? Farouk, are we together? Farouk. Okay. Letitia.
We are together.
Letitia.
Yes, teacher.
We are together, eh?
Yes, teacher.
Then that is very good. Now exercise. I cannot leave you without giving exercise. I cannot leave you without giving exercise. Exercise. The question is not on the screen. The question is not on the screen.
Yes.
I'm going to give the question, okay? Okay?
Yes. Okay.
But these things are very simple. Now all of you are going to pass. Now you see this kind of question here. We have done all the add questions. We have done all the add what? Okay, exercise. We are running out of time. Let's try to array. Number 1, a ray of light is incident on air to glass interface at an angle of 60 degrees, full stop. If what? If the refractive index of glass is 1.52, comma, find the angle of refraction. Find the angle of what? Refraction. Okay. Number two. Now this one, I want you to use the other formula or refractive index. So that's saying the speed of light in air, is 3.0 times 10 to the power 8 exponent that. And the refractive index. Remember, our time is running out. And the refractive index of glass is 1.5.